Hello everybody, so in this video we're going to talk about linear equations, and we're going to start by looking at the three main types of linear equations. Okay, so one of the main forms for linear equations is called standard form. Okay, now this form is actually related to the x and y intercepts that we saw in the previous video. Okay, and it is the form that we saw in the example in the previous video. So it looks like ax plus by equals c. Okay, so it's the form where we have both x and y on the left, and we have the number part on the right. Okay, so for all these forms, x and y are our variables. Okay, and every other symbol is going to be a number. So when we look at standard form, we're going to be looking at A, B, and C being number values. Okay, so an example of this, like I said, there was one in the previous video. We might also have something like 15x plus 2y equals 7. Okay, so this is an example of an equation in standard form. Okay, now these numbers 15, 2, and 7 are related to the x and y intercepts, but they're not exactly the x and y intercepts. Okay, now for the form that students are most familiar with is usually the slope-intercept form. Okay, and this is the y equals mx plus b form. Okay, now remember, only x and y are actually variables. M and b are not variables. Okay, so in this example, m is going to be the slope of our line. Okay, and b is going to be part of the y-intercept. So the ordered pair 0b is the y-intercept. Okay. Now let's talk a little bit about what the slope of a line is. Okay. So the slope of a line is a measure of how slanted it is. Okay, so a large slope is going to mean a line that is very much more vertical, okay? And a small slope is going to be a much flatter line, okay? Now, more precisely, right, we're going to define the slope as being a fraction where the numerator is the vertical change or the change in y. Okay, and the denominator is the horizontal change, okay, or the change in x. All right, so that's what the slope is all about, okay, and we can see that this is the slope and this is the y-intercept, okay. And the last thing we're going to look at is called the point slope form. Okay, now this one looks a little bit more complicated, and each of these different forms has their pros and cons. Okay, so in this example, oh, I forgot to give you an example of a equation in slope-intercept form. We might have y equals 2x minus 4. Something like that is in slope-intercept form. Okay, now in point slope form, m is still the slope. Okay, and now we don't have the intercept, we just have some random point on the graph. Okay, so x1, y1 is any point on the graph. Okay, so an example of what that might look like, we might have y minus 3 equals 2 times x plus 1. Okay, something like that is going to be point slope form. Okay, so I want to get started talking about how we're going to use this to actually write the equations of different lines. Okay, now when we write the equation from different information, we are mostly going to be using the point slope form and the slope intercept form. Okay, so let's go ahead and start with some examples. Okay, so first, let's look at an example where we're given information about the slope. Okay. Okay, so in this example, we are given the slope and the y-intercept. So the first thing we want to do is pick out the form that we're going to use. Now, the way that the forms are named usually tells you which form to pick. So because we have the slope and the intercept, we're going to use the slope-intercept form, right? Or the y equals mx plus b form. Okay. Now we already know that the slope is -5, so I'm going to put that in my equation for m. Okay, and remember my b value, right, is going to come from my y-intercept. My y-intercept is going to be 0, comma b. So my b value in this example is 2. Okay, so if you have the slope and the y-intercept, then you can go ahead and just fill that information in. Okay, let's look at another example. So let's look at this. So the information that I have is the slope, and I have a point on the line, and I know it's not the y-intercept, right? The y-intercept is always going to be 0, comma, number. So for sure this is not the y-intercept, okay? So instead of using the slope-intercept method, because I don't know the intercept, I'm going to use point slope form, okay? So remember that form is y minus y1 equals m times x minus x1, okay? So x1, y1 is my random point, so that's going to be this point here, x1, y1, okay? And m is my slope again. So I'm going to have y minus -7 equals 1/2 times x minus 4, okay? Now, a lot of students are tempted to simplify this into the y equals mx plus b or the point slope form. You don't really need to do that unless the question specifically asks you for it, okay? What I would say is that you do want to simplify this double negative. So y minus -7, that's going to be the same as y plus 7. Okay, and that's the only thing I'm going to simplify unless the question specifically asks me to put my answer in a different form. Okay. All right. So these are the two most basic examples. So I want to talk about what to do if we don't have the slope of the line, okay? Because in both of these examples, we were just given the slope of the line, and that's something that's not always going to be the case, okay? So I want to remind you of what we said about the slope, right? We said that m was the vertical change divided by the horizontal change. Okay? Now, the vertical change is going to be associated with the y variable, right? So this is going to be the change in y over the horizontal change. That's going to be associated with the x variable. So this is going to be the change in x. Okay? Now, from an equation or from points, the way that we might look at this is the change or the difference, right? We might say this is the difference in y. That's another word for change. Okay? But in math, difference has another meaning, right? We know that difference means subtraction. So we're actually going to take 2 points and we're going to subtract the y values, and then in the denominator, we're going to subtract our x values. Okay? Again, x1, y1 is just a point on the graph. Okay? And x2, y2 is also a point on the graph. Okay? So let's look at an example of finding the slope. Okay, so this is a really normal example where we just have 2 points that the line is going through. Okay, so we're going to use our formula that we have up there. So we have y2 minus y1 over x2 minus x1. Okay, now I'm going to label this first point as x1, y1, and I'm going to label my second point as x2, y2. Okay, so that means y2 is 10 and y1 is 4, x2 is 5, and y2 is 2. Okay, so this is going to give me 6 over 3 or positive 2. Okay, I want to point out that if you decided to order these differently, so if you decided that you wanted to pick the first one to be x1, y1, or if you wanted to pick the first one to be x2, y2, and the second one to be x1, y1, how would that affect this? Let's look at that. Okay, because a lot of times students ask, does it matter what order I go in? And so I want to answer that question. So let's say this one is x2, y2, and this one is x1, y1. Okay, so we're just labeling them differently. So our slope is going to be y2, which is 4, minus y1, which is 10, over x2, which is 2, minus x1, which is 5. Okay, now 4 minus 10, that's negative 6, and 2 minus 5 is negative 3. Okay, so remember, a negative divided by negative is a positive, so I have 6 divided by 3, which is still positive 2. Okay, so no matter which way you order the points that you have, it won't matter. You'll still end up with exactly the same slope. Okay, now let's go ahead and do one example of writing the equation when we have just 2 points. Okay, we looked at how to find the slope based on 2 points, and I want to do one example of writing the equation based on 2 points. Okay, all right. Okay, now when we have something like this and we want to write the equation of the line, no matter what information we're given, the first thing we need to do is find the slope. Okay, so let's go ahead and find our slope. Now, because we know it doesn't matter, we're just going to go ahead and label these as x1, y1 being the first and x2, y2 being the second. Okay, because we learned in the last example you can do it either way. Okay, so y2 minus y1 is going to be negative 1 minus 5. And then in the denominator, I'm going to have x2 or 14 minus x1 or 2. Okay, so negative 1 minus 5 is negative 6, and 14 minus 2 is 12. So I am going to reduce my fraction. It's still negative. 6 over 12 is going to reduce to 1/2. Okay, so now I have the slope, okay, and I do have 2 different points. So I'm going to go ahead and use my point slope form. So I have y minus y1 equals m times x minus x1. Okay. Now, sometimes students are worried that it still will matter which ordered pair they picked as 1 and which one they picked as 2. And just like with the slope, it absolutely does not matter which one you have picked as 1 and which one you've picked as 2. Okay, so I'm going to fill in my y1. My slope I know is negative 1/2. Okay, and then I'm going to fill in my x1, which is 2. Okay, so you can use either point for the point slope form, but because it says x1 and y1, I'm just picking the point that I had already labeled as x1 and y1. Okay, so these are the main examples of how to write a linear equation based on the slope and the y-intercept, the slope and a point, and 2 points. We'll talk about other information that can lead to the linear equation in class, so I will see you there.